Good afternoon and welcome to today's webinar, Nutrient Balance, What's in it for me? So just a little bit of housekeeping before we kick off. So Chris, would you mind sharing your screen? Thank you. The housekeeping slides, please. Thank you. So all attendees will be muted throughout this. We are planning to run until about 1:30. However, if there's lots of questions, then we can potentially roll over. So we'll keep going as long as there are decent questions. So we may run over 1:30 slightly. This is going to be recorded, so you can rewatch afterwards and share with your colleagues. And at the very end, there's going to be a survey. So it really helps us shape how we run these and the content that we run. So if you have time to fill in that survey, that would be fantastic. Next slide, please. So you'll see that there is a question box. So a little speech bubble with a question mark in. Type that. That will open up the question box for you to type your questions in. I think it'd be great if we could have questions coming in throughout, and we'll do our very best to get through them all. If you are struggling with any technicalities, next to that box where there's the paperclip, there are some notes there, so you can have a look at that to troubleshoot any issues that you may have with the program itself. Thank you, Chris. So today's webinar, nutrient balance, what's in it for me? What I'd like to do is introduce Gavin Green and Keith Davies from Lydney Park Farm, one of our strategic dairy farms, to kind of introduce the farm and why we are talking about nutrient balance today.
Good afternoon. Yeah. So Lydney Park Farms, we spring block calving 850 cows, and we've been doing that for 17 or 18 years. Nutrient balance probably flagged up to us in the report we did early in the year with Brendan Horan as part of the strategic farm process, and just see it as another area for better and more efficient production and just generally an efficiency, identifying some waste in the system that we can try and drive out.
Fantastic, thank you. So within that review that Brendan, and I should probably say as well that people can go to the AHDB website, have a look at the Lydney Park Strategic Farm page and find out more information about that whole farm review that we did. But you were challenged within that. You had a nitrogen surplus of 168 kilograms per hectare, and the challenge from Brendan was to drop that down to 100 kilograms of nitrogen per hectare. So we kind of asked, was that a fair challenge? What exactly is it? How do we do it? And kind of what's in it for you? What are the advantages for you by reducing that nitrogen surplus? So that's why we brought Chris Duller in. So Chris, would you like to introduce yourself?
Afternoon, everybody. Yes, thanks for attending on a sunny afternoon. It is in Wales anyway. And giving up your daily fixer bargain hunt on the telly. Yeah, today we're going to run through the whole business of basically nutrient accounting. And I've got a short presentation, he says short, just outlining the basics of the whole idea of nutrient use efficiency. I'm going to bring all the others in, whether they want to or not, and ask them some nasty questions. And I'd encourage you all to chip in with some questions. And I say we'll get into some of the detail about how you can all do your own nutrient balance with software that's freely available. And I say, with a bit of luck, we'll have plenty of time at the end, Tom, for some decent questions.
Fantastic. So the rough plan is you're going to talk to us about what a nutrient balance is. We're then going to hear from Lee Truelove from First Milk about why nutrient balance is important for First Milk. And we're then going to come back to how to calculate the nutrient balance and have a discussion about why farmers should be doing it using a case study of what's happening at Lydney.
Yep,
wrap up with any questions and a summary around about 1:30.
That's right. Yeah. Okay, if I can get my Screen back up. Okay, just as a part of the confusion to it all as well, I'm aware that we might have some people coming from different parts of the country, and if you're in Scotland, you have a different system. So when I'm talking about indexes, in England we have RB209 and the DEFRA system, and everything's on a 0, 1, 2, 3 scale. 2 being target for phosphate, 3 we start to get excess, and 4 is just going way over the top. In Scotland, you have a descriptive system, and if anybody happens to be from Ireland, you complicate matters even worse, and you have a different descriptive system. But there you go. Just to clarify, I'll be using when I talk about indexes, I'll be on the DEFRA scale. Okay, so yes, farm nutrient balance. What's in it for me? There's been an increased focus over the last 30, 40 years on resource use efficiency. And all right, I'm getting old now, but my career started in soils, and everything about soil management was really looking at maximizing yields and productivity and improving efficiency from a production basis and an economic return on investment. And then in the last 30 years, increasingly, the environmental focus has been on there as well. So when we're looking at soil management and how we use fertilizer and slurry, it's been, okay, we want to maximize grass growth, but we also want to reduce any losses to the air and to water courses. And in line with that, we've had nutrient management plans, manure management plans. We've got advances in technology with the low emission spreading systems, which is what LESS stands for. And a lot of that resource use efficiency for soils and slurry has actually been driven by legislation as well. And if we look at, for example, nitrogen use in the early 80s has come down by about 70% in the last 40 years, partly because we're making better use of slurry and partly because of legislation. My other focus for me, all right, I spend a lot of time digging holes and looking at soils, but we've been looking at the whole business of grazing management. Effectively, there's no point in growing grass if we don't utilize it. So we've had all the work looking at paddock systems and measuring grass. And so why Gavin and Keith are out busy measuring grass, well, they don't. They delegate now, I'm sure, but they used to. But all that's about improving utilization and maximizing that efficiency. Nobody pays you to grow grass. We've got to use it. And normally in my line of work, that's kind of where I stop. But then there's this whole other area of resource use efficiency in the actual feeding process and the actual conversion of all that nutrients in forage into milk. So we've got vets involved and nutritionists, and it's all about maximizing the output per animal, improving all the reproductive indexes. And ultimately, we've been looking at the nasty terms of nutrient use efficiency. So effectively, if we can control all these aspects of the system, we can get the most out of, for every kilo of nitrogen we put in the front end, hopefully we'll get a good return on that, maybe 30–40% of it back out in milk. We're also looking at what we call the nutrient balance today. So effectively, how much nitrogen goes in and how much comes out. It's very similar to where we are with the carbon footprint, that idea of a nutrient balance. So a lot of you will have completed a carbon footprint where you look at what comes into the farm and what goes out. And all we're going to do is apply that to nutrients, primarily nitrogen and phosphorus. And we're looking at resource use per kilogram milk solids produced, or we can look at resource use per hectare or per cow. Now, let's say efficient use of nutrients, you can spend an awful lot of time focusing on the storage and the application and how we spread it and how much grass we grow. But unless I look at the whole process through to conversion, it's actually pretty much a waste of time. And I see lots of nutrient management plans where they say, oh no, don't put any slurry on that field, phosphates are too high, put it somewhere else, without realizing that on a whole farm basis, all we're doing is actually taking the rest of the farm up to this very high level as well. And actually something needs to change on a farm scale. So yeah, we're very used to looking at nutrient balances on a field scale, but what I want to do today is look at it on this sort of whole farm approach, and it's called effectively a farm gate nutrient balance. So it's what comes into the farm, fertilizer, feed, bedding, what comes out in terms of livestock output, and we're looking at either an excess or a deficiency. So say your big inputs, feed, fertilizer, bedding, milk and meat to your output, and my excess is either in a kilogram per hectare. And if I look at my nutrient output and divide it by my nutrient input, we get what we call this nutrient use efficiency. So that's effectively what have I got in my milk tank as opposed to what came onto the farm in terms of fertilizer.
Chris,
we can also look at that. Yes.
Is it possible for that to be completely balanced? What is the most efficient that one could achieve?
Well, it's a leaky system, and this is the problem. So I'll come on to, the inherent problems with a ruminant is that 70% of the nitrogen we put in the front end falls out the back end. As soon as that nitrogen hits the deck, it's either going upwards as ammonia, can be released as nitrous oxide, or it's sloshing out at the bottom of the wheel as soluble nitrates. So the nitrogen side of things, we're up a challenge all the time to try and get as much as we can into effectively milk and meat by the limitations of having a ruminant and having a very volatile soluble substance of nitrogen. Phosphates are a little bit easier because phosphates don't convert to a gas. They're not readily soluble, so they don't disappear in different directions. So in terms of phosphorus use efficiency, we've got probably more scope to get closer to a balanced system than we have with nitrogen. So say on a field scale, we do it all the time. And for those of you with a nutrient management plan, you've got a copy of RB209, you've got a soil analysis, and we know what the crop needs at different levels of nutrients in the soil, and we know how much nutrients to apply to maximize crop yield. And we've got years and years and years of data and trials to back up that. And effectively, if you're in excess, so if you're applying too much nutrients, you'll increase your soil nutrient status, potential to increase losses, and there is an economic inefficiency there in that we're wasting nutrients, we're bringing stuff in that we don't need. Now, legislation, as I say, has dealt with quite a lot of that on a field scale. If we're not providing enough nutrients for our crop offtake or our animal offtake, then we'll reduce soil nutrient status. We can have below crop yields, quality. It can also impact, obviously, on the animal performance as well in terms of for example, trace element deficiency and everything else. And there is an economic inefficiency in that suboptimal soil nutrient status. Increasingly, you can also argue there, if I've got soils that are low in nutrients, there is now habitat opportunity. So particularly over here in Wales, a lot of people are now looking to tick a box that says we're going to have 10% of the farm as habitat. There is no point me trying to put a field into habitat that's got a phosphate index of 3. At those sort of phosphate levels, grasses are going to dominate. We're not going to have diversity. It's not going to be habitat. Whereas if I've got deficiencies and I've reduced my soil nutrient status, then all of a sudden it gives us more opportunities on that side of things. That's another whole session, Tom. We can talk about that. My job effectively out in the field is to improve nitrogen efficiency. We're looking all the time at promoting healthy soils, keeping pHs where they should be, thinking about our fertilizer products and the rates we use, when we chuck out the slurry and the manure. And increasingly now we're looking at other areas such as biostimulants that people are getting interested in. How can we reduce the amount of nitrogen fertilizer we use without compromising grass growth? From a phosphorus point of view, we're looking at, all right, the key is get your soil samples, know where your phosphate status is, maintain your pHs to maximize its availability, and people are then fine-tuning phosphorus usage, looking at placing fertilizer P. The maize boys are still putting P down the spout. Phosphorus isn't mobile. It's most effective when it's right next to the root base of the plant. A lot of interest now in foliar P, trying to increase that plant uptake, protected P products, and we've got a lot of schemes in place trying to reduce the runoff. Effectively, if I've got too much phosphorus, there's not an awful lot I can do about it, as long as I keep it in the field. So effectively, a lot of methods are now employed to try and reduce soil erosion and try and keep that P in the field. So at a field level, we're looking at the efficiency, what we use, what response we get, and all right, that is always going to be compromised like we are at the minute with weather conditions, but that could be pests and disease and everything else influence those responses. And all right, I'm not going to go mad on graphs today, I promise. This is my graph of a fertilizer response curve. The green one is a nice healthy soil, And if I apply, as I increase my nutrient input, I increase my yield to a maximum, and then it starts to drop off. My red line is a field where maybe I've got compaction or I've got a lower pH. My crop doesn't respond to the same way, so my line has a lower gradient and drops off a lot earlier. Now, with regular soil sampling and by improving all my soil health and my soil quality, we can increase that response to fertilizer, to applied nutrients, so that the steepness of that line increases. I'm also interested in increasing that soil nutrient supply, so that area in that blue circle. What do I grow for nothing? Because a field will grow without you putting anything on it, because your field has soil nitrogen in a form that breaks down over the course of the year and delivers nitrogen in an available form to plants. In a healthy soil, that could be enough to produce 7, 8, 10 ton of dry matter. In a poor field, it could only be 2 ton. So those are the areas we're interested in, is maximizing response, but also increasing what soil gives us for free effectively. And typically with response, I try and work on 30 kilos of grass dry matter grown for every kilo of nitrogen we apply. And then if we're looking at what we can get for nothing, 7 ton would be a really good starting point. So if you're applying 200 kilos of nitrogen at 30 to 1, that grows you 6 ton of dry matter. If you're already getting 7 ton for nothing, then you should be looking at somewhere around about 13. That's the way the sums work. If I take out all of that bagged nitrogen, I need to then have an increase either in what my soil releases, or else I need to look at inputting nitrogen from another source like clover. So, okay, we've done lots on the soil. We've also done lots on the animal side of things, looking at nutrient use efficiency in the animal. And again, it's what comes in the front end, just like we are in a field, what comes in the front, what goes out. And that's all about how animals utilize the nutrients, their feed conversion efficiency, and we can play around with diets and supplementations. The problem we've got, as I say, in a ruminant is an awful lot of nitrogen never makes it into milk and meat. With phosphorus in ruminants, somewhere between 30 and 40% slightly better, but there's still a lot that's coming out of the system. I say in a ruminant, 20-30% goes off in milk protein, and we're looking at how we formulate diets. We've had advances in things like high sugar grasses. We've got feed additives, genetics are looking at feed conversion efficiencies. At the back end, so to speak, we've also got a lot of work looking at how we manage slurry in houses to improve or try and capture some of that nitrogen that's falling out the back end before it even gets to soil. From the phosphorus point of view, there's a lot of work looking at how we feed dairy cows. We have quite high phosphorus content in dairy rations, probably, well, definitely more than the animal actually needs. So there's a lot of work being done, certainly here, and if we look over in Holland and certainly in Ireland, at reducing the P content rations to try and reduce what goes out in excreta. And I say most of that is in the solid portion. So there is no P in P effectively. So when we look at slurry separation, all of that phosphorus we can extract in the solid portion. So we can put the separated dilute watery slurry out onto fields where there isn't a P demand, and then we can put the separated slurry onto areas that have got a phosphate demand. We've taken that a step further now. Some places are looking at actual complete phosphate stripping, and in an ideal world we could then sell that phosphorus to other users. We can even take it as far as converting it into a fertilizer that we sell in B&Q in little bags for people on gardens and the like, and add value to it. So my chart, well, the aim of today is to basically link these two, the whole idea of grass and soil one end and animals, and try and make this farm gate balance where everything looks on a whole farm scale. And the biggie is how we recycle all the muck that we gain from the animal back into grass and in a healthy soil. So what we're going to cover in a minute is the whole business of how we do this farm gate nutrient balance, what we need to know in terms of data to be able to work out our kilo nutrient per hectare balance and our nutrient use efficiency. Okay, I'm going to stop sharing screens now and say, really, Lee, I guess I'd like to come to you and ask, well, from my point of view, I see the importance of looking at soil nutrients in detail. I've never really got involved in the animal end of things. Where do you sit as an industry? I know you've done a lot of work in the past looking at nutrient use on farms. Where are you heading lately, Lee, with your producers?
Thanks, Chris. Yeah, good afternoon, everyone. I think I'd start by saying, and you've already made this reference, that carbon footprinting is now relatively normal for most, and in essence, most of the information is available to calculate what we call a nutrient footprint. And why wouldn't we want to know that information? Because I think, particularly with the poultry industry, we've seen what the consequences might be if we don't sort of work out what to do to minimise nutrient leaching. Tom has just said I need to introduce myself. I thought that was your job, Tom. I'm Lee Truelove, head of Regen Farming at First Milk. So yeah, Chris, everything you've said is obviously you're coming at it from the, if you like, from the supply side. From the demand side, I guess there's two or three main sort of influences here. We know there's the governmental one. There's obviously the customers are really interested that there isn't anything in their supply that could cause issues. And then increasingly what we're finding is that the sort of rivers trusts and environmental NGOs not only are interested in this, but they're sort of recruiting people that really understand it. So that's why we're interested in it. Thankfully, there isn't any extra information we need from farmers. The carbon footprint will provide pretty much everything we need because we've got obviously the milk sales already. So I think it's really a case of learning at the moment as opposed to sort of judging people. So learning what really big excesses look like and perhaps learning from those that might be more in balance. So that's the sort of quick overview at the moment. I can come back to more detail later.
Thanks,
Thank you,
Lee.
Lee.
Yeah. Sorry, Tom, go on.
Yeah, so as a co-op, First Milk, how are you supporting farmers to improve their nutrient balance? And is this something that's being echoed by other processors?
I'd say, Tom, this is brand new for the whole industry. So I would be so bold as to say I don't think there's an awful lot going on at the moment other than understanding the data. But what I'm keen to do, and what we've done with our strategy over the last certainly 5 years, is try and deal with that word holistic. So if we're too carbon centric, we'll get unintended consequences, and one of those unintended consequences could be we're out of kilter on nutrients, because if your carbon footprint doesn't, well, it won't assess whether you're losing anything to the river particularly. So the unintended consequences of the industry is headlong to net zero, but with a real big sort of water issue. So I think the best thing we can do is say let's not drive people too extreme in any one direction. Let's try and be holistic. So we've got an overwhelming water strategy as opposed to just the nutrients issue. And I'm from Herefordshire. A big chunk of the country's had a hell of a dry year. Ironically, Cumbria, for instance, have never had so much grass, and West Wales, I think, sits in between. We're doing quite well and have dried up a lot lately. So water resilience is a really key issue, but also, as I said, the public are very active in this space, or a certain section of the public, and they do influence our customers. So rather than have an adversarial relationship, we're partnering with people like West Wales, Cleddau Rivers Trust or Cleddau Action Group, the Cumbria River Trust, Eden's Rivers Trust, etc., because they have access, directly and through other organisations like WWF to the big retailers and our other customers. So I think at the moment it's let's understand the numbers. We're not interested in anybody being seen as a criminal or a hero. It's too early to sort of make those judgments. But like anything, unless you've got a speedometer, you don't know what speed you're going. So it's just to understand the numbers at the moment.
Thank you. So, Chris, it'd be good to, obviously we've just spoken about what the nutrient balance is. It'd be good to have a look at how people can calculate their own and what the benefits are to reducing the surpluses.
Good. Yeah. I apologise. Some of this, it's spreadsheets for a minute, but stay with us. Okay. Okay. So effectively, let's say how we calculate our nutrient balance is simple. What comes onto farm, what leaves the farm. And as Lee says, all this sort of data will have been used if you've been doing carbon footprinting. Now, there is a free available package of software out there. Some of you may have had experience of using Planet. It's designed as a nutrient management plan to enable you to be compliant with all the rules and regs. Web address up there, planetforfarmers.co.uk, free to download, doesn't take up a huge space on your computer, easy to use. I say easy to use. Some of the nutrient management stuff, it's easy to use when you're familiar with it. But what we're going to look at today is what we call the farm gate nutrient balance. And once you've downloaded the program, you don't have to do anything else, fill in anything else. We can go straight to just looking at the farm gate nutrient balance. And if you click on the little symbol of a gate, it will allow you to enter that part of the program. And front page is all about just setting the area, how much grass, what area of grass have you got? 250 hectares. I've got 100 hectares of cereal, say, and then I've got some clovery grassland in there. And we're interested in looking at the two different types of grassland because obviously in that grass clover, 200 odd hectares, there will be an input from fixation if we're lucky. So I'll just run you through the process then of adding data to get our nutrient balance. And we're looking at imports, exports, and then we'll look at the output at the end of it. So in terms of imports, we've got livestock imports, animal feed, bedding, manures, fertilizers. So I'm going to kind of use some of the examples that we've run through with Keith and Gavin. So typically, if I've got cattle coming into farm, we might have some heifers coming in. So there's not a lot of imports coming onto Lydney, but some of you might have heifers coming in. Some of you might have beef animals coming in. Animal feeds, there's a drop-down menu within the spreadsheet to allow you to pick any feed you want, pretty much so. And it has a pre-populated crude protein level, phosphorus level, or you can go and find the label on your bag and actually type it in so you get your own numbers in there. There was some research done. AHDB funded a PhD project looking at phosphorus in animal feed, and 80% of people didn't have a clue the level of phosphorus in their cake. So say there's tons of options, and here we've got just a dairy compound feed. Again, we can vary protein percentages. I've got a little bit of soya coming in, and we've got some dry forage coming in for dry cows. I say across there, it works out how much phosphorus is coming in. It also allows you to do a little stock balance as well. So what's in stock and what you've used in that calendar month. Next one will be bedding. So for most of you, it'll either be straw, sawdust, combination of the two. And again, it's already got a pre-populated what's the NP in straw, so it knows what's in there. In terms of organic manures, it gives you an option if you're taking things like biosolids, digestate, all those things give you an option. And then when it comes to fertilizer, again, type in drop-down menus, allow you to select the amount of nitrogen in your products that you're bringing on, how much is coming on farm, and again, there's a stock take allowance in there as well. So relatively simple information based on a calendar year, what comes onto farm: animals, feed, bedding, fertilizers. In terms of exports, I've got calves going off and I've got cull cows going off. And I say some of you might have an extra complication of having beef cattle going off, but there's allocations in there. You just select your livestock type, stick in its weight, and it will calculate the amount of phosphorus and nitrogen leaving in that stock wagon going off farm. Then if we look at products, there's only two products effectively. It's either milk or we've got eggs, because the other livestock product of meat is in that livestock export area. And all we're looking at is, you can put in your own milk protein levels, and then how many litres are leaving farm. So a relatively simple way of just typing in what comes off farm. There's a area there we can look at. If you're growing some cereals and you don't keep it all, some of it goes off farm. It allows you to put in your straw and your grain, what's kept and what goes off. And again, if you're in a position where you're exporting manure from the farm, we can deal with that as well. At the end, we can then look at the output, and it summarizes your imports. And typically for most farms, the big imports will be animal feed. Particularly when it comes to phosphorus, typically we find 60, 70, 80% of the phosphorus coming on farm will be in the form of the animal feed side of things. So here it's coming in that dairy cake. A little bit coming in, and the example we've got here is from Lydney Farm, where they've got a little bit of TSP coming on to correct low P6 fields. So those are my inputs of phosphorus, and it gives me a grand total there. It sounds a lot, 112,000 kilos of nitrogen across the farm area of 573, I think we are at Lydney. The exports, again, we've got a small amount going off in livestock and a large amount going off in milk. And then ultimately it will give you the balance, and this is the balance for the whole farm in terms of how much nitrogen comes in, and that works out, all right, slightly different from where Brendan's figure is marginally, 161 kilos in excess of nitrogen, and 26 kilos of phosphate. Now, be careful. One of the problems we have with nutrient balance is that Planet reports its phosphorus in phosphate rather than phosphorus. So a lot of other data out there, and certainly a lot of published data, will look at it in terms of phosphorus, not phosphate. So if I want to get back to elemental phosphorus, we divide it by 2.29. So it works out 11.3 kilos of phosphorus per hectare. And it's one of the big problems we have with nutrient balances is that we need to make sure that everything we're putting in terms of the P content of feed is in phosphorus and not phosphate. And I say the Planet does it all for you, so there shouldn't be a headache unless you start trying to type in your own data. Just be careful that you're actually dealing in the right form of P, phosphorus, not phosphate.
Chris,
okay, so that's
questions coming in from the audience. Which is most important to improve, P efficiency or N efficiency? Is it possible to focus on those two things separately, or should they be focused on as one?
So certainly, depending on where you are, currently, if we look at, we're in Wales, the big focus at the minute is on the phosphorus levels in the Y, and phosphorus is getting huge attention. Phosphorus is probably the easier one to address and understand, because I say there's less things disappearing. When it comes to looking at a nitrogen balance, there's an awful lot of unknowns in that system, as in we don't know what goes into soil storage. We don't necessarily know how much disappears in different directions. Phosphorus is probably the easiest one to do. Is there a more important one? Again, if we come back to things like carbon footprint, if I want to really reduce my carbon footprint, then reducing nitrogen fertilizer has a huge impact. So it depends on what focus we want to look. In terms of water quality, I say phosphorus is your biggie. So it depends where you are and what your risks are. Ideally, they're probably both going to be done at the same time if we can manage our feed levels and balance up with fertilizer. It's yeah, I'm not going to stick my neck out and say one's more important than the other. Sitting on the fence again. Any more nasty questions, Tom?
Keep going for now. I'm going to see if some of these are already answered.
Good. Okay, so I hate numbers. I love graphs, so I've put it into a graph. Nutrient nitrogen balance on the left, 161k, and you can see that big red swipe is nitrogen fertilizer, and on the right side, the big red stripe is the bit of TSP that comes in. If I divide my inputs by the output of nitrogen in milk and meat, I get a nitrogen use efficiency of 24% and a phosphorus use efficiency of 45%. Okay, so yeah, good or inefficient? Is it a problem that I've got 161 kilos of nitrogen? Well, Brendan thought so. He wanted it down at 100. Is it a problem I've got 11.3 kilos of phosphorus? So that's 23 kilos of phosphate per hectare in excess. Do we take action or are we okay? Now, isn't the simple answer that we just look at those big red bars and go, right, stop spreading fertilizer, Keith? What are you doing? Killing the planet. It's not simple as that, in that if I stop spreading that fertilizer, I grow less grass. And currently Lydney's growing somewhere between 11 and 12 tonne of dry matter. If I take that nitrogen fertilizer out of the system, I've got to find fertilizer, I've got to find nitrogen from somewhere else. Now, if we went to a 0N system and we put in clover, how much nitrogen would clover fix? Well, in New Zealand, they quote figures of 150 kilos of N. In subtropical Gloucestershire, would we get 100 kilos? Possibly. I'm not going to be growing on a consistent basis, probably the levels of grass that we are at the minute. Currently, I say I've got 8 kilos per hectare coming from that TSP, but it is being used to raise those low P status fields. So could I actually maintain my P status with nearly, what we got, over 3.75 million litres going off in the milk tank, that big lump? So I've got a total of nearly 9 kilos of phosphorus per hectare going out on a milk tank. So could I maintain soil P without fertilizer coming in? It's going to be very tricky. So I think there's always going to be some element of P input required because we're not feeding a lot of cake in this system. So we are almost mining P. When we get below about 3/4 of a tonne of cake per cow, we are mining phosphorus. I think Lydney is slightly just above that, but it's still quite marginal. Okay, I'm just going to stir the pot in the clover business. So this is a study looking at the effect of 3 treatments. I've got grass only with 250 kilos of N. I've got a grass clover sward with the same amount of fertilizer, and then I've got a grass clover sward where they've dropped fertilizer inputs by 100 kilos of nitrogen. And they're looking here at the nitrogen balance. And here we have fertilizer inputs across the top, a little bit from cake, a little bit from deposition. So they've done the nitrogen balance in terms of what comes in and what comes out. And they've got a surplus in that 250k of 150 and an N use efficiency of 40. And where they've got clover in the system, they've taken their nitrogen use efficiency up to 59 and they've halved their N surplus. Wow. Okay. That's one way of looking at it, is that we're using nitrogen fixed and we're replacing bagged fertilizer. So we've improved our nitrogen use efficiency. Now, if I assume that clover fixes 80 kilos of nitrogen, so rather than that nitrogen input being 175, in reality, it's actually 255 because I've got 80 from clover. It is still, in my argument, an input because it's not an improvement in nitrogen use efficiency as a whole. It's still providing nitrogen in the system that can be leached, that can be converted into nitrous oxide. It's an improvement in economic efficiency. It's an improvement in your carbon footprint because you're not using fertilizer. And it's a good headline for milk producers to say we've reduced our fertilizer use and more reliant on clover. As a purist, I still argue that clover and nitrogen is exactly the same form as it is in the bag, and it still presents us with a leaching risk. Now, I'll bring in, because Lee will argue this one. Lee, you don't agree with me on this 100%, do you?
Like all these things, Chris, it's a debate, a bit of nuance, isn't it? I think sometimes we got to figure out what our social license is. So I sometimes think about how we communicate this to consumers. And I think that's where, a clover sward will be seen as, if in inverted commas, more friendly nitrogen. It hasn't had natural gas to produce it, and it's absorbing nitrogen from the atmosphere on the farm and then recycling it. So it becomes what people call a biogenic cycle, as opposed to a thermogenic cycle, which requires burning of something to make the product happen. So I think, there's the sort of chemist's view. As you say, Chris, it's still nitrogen efficiency, but then increasingly, I think we're saying, what is the biological view as opposed to the chemist's view. So appreciate it's a good debate, but the consumer would probably say the one is a little bit more welcome than the other. So that's that's
Yep.
like I said,
No,
a
I
bit
say
nuanced.
the scientists can't agree whether we take it in a balance. Keith, Gavin, what's your thought on, if I'm going to get my nitrogen inputs down, is clover the logical way for your farm to go?
I think it's got to be part of it, yes, especially when if it's replacing bagged nitrogen. And I get your point completely, Chris, but we still have to grow something.
Yeah.
And to some extent, it's cheaper, isn't it? So therefore, economically, it's the better way for us to go.
Yeah, I think the economic arguments stand up, and I say I'll get back in my little box, but I still say it's a nitrogen input, and I'd rather see nitrogen use efficiency being improved by healthy soils and utilising. We could have 8, 9, 10,000 kilos of soil nitrogen in there in an organic form that we can utilise if I improve soil health, increase rooting depth. I see that more as improving nitrogen use efficiency than turning around and going, oh, we got clover. But there you go. Right, sorry. Let's get back to...
Well, just before you do, Chris, I've got a question coming in from the audience here. How does the balance of P work where you have TSP going onto low P index fields, but perhaps getting slurry onto high index fields? Or is that where you suggest separation?
Yeah, so all this business of can I get enough slurry back onto a low status field to raise a P index without damaging grazing performance? And it's very difficult to do. We don't want to be putting thick slurry on grazing fields that have got low index. And if I put the thin watery slurry on it, there's no P. So it's a big challenge how we raise P levels. We either run down a periodic hit of TSP to raise them, or we use a product, early bite 25-10-0, to trickle it in to a certain degree. But yeah, balancing up slurry across the whole of the grazing platform is always going to be tricky. And I say one of the biggest problems we have is that if I start saying, oh, you can't spread slurry on that field because it's index 4, that's then got to go somewhere else. And the danger is that all we do is raise our everywhere else on the farm up to a high status. So the one good thing about this whole farm balance position is we can identify a P excess. We can then identify a definitive need to export phosphorus off the farm in a form of slurry manure. And there will be some farms that it's the only way of reducing their P status.
And there's another question here about foliar N. Does foliar application of N reduce total N? Is it worth doing?
Okay, so you try and find genuine research on foliar N applications. There's a lot of anecdotals effectively saying that we improve nitrogen use efficiency by going directly through the plant rather than through the soil. In conditions like we've got at the minute with drought and low soil moistures, there will be an improvement in nitrogen uptake from a foliar as opposed to a granular application. In terms of what we tend to find is that most people who use foliar don't see it consistent as we do with granular. Some years outperform other years. If I'm going to be going down the foliar route, there is potential, and the biggest potential is probably where I've got damaged soils, poor rooting structures, we might be able to get more through the plant. Research is really not there, and it's a big area that we need to look at. There's a lot of people doing it, and again, we're limited in what we can apply as a foliar spray to urea products, so the issues about losses in that sense can be quite high. And if I'm using foliar, then I have to wait for a recovery period before I can get my foliar spray onto a leaf. So if I've had a grazing and I've nailed my 1400, 1500 residual, I've got to hang around for 10 days before I can go and apply my nitrogen because I haven't got a leaf to spread to. So my answer is, it is not conclusive that foliar is any better in terms of nitrogen use efficiency on a long-term basis. Okay. Right, so that's my rant about clover over. Sorry. Let's just look at some of the other research out there. So I remind you that the output, the end balance is about 161, and inputs in total at Lydney Park is 212. So this is some data from a New Zealand study where we're looking at a similar end input and a result outputs about 55 going off. So again, similar, a 30% nitrogen use efficiency, and end surplus is 131. That's an intensive dairy setup. There's also some data from Dutch farms where there's a lot more milk coming off per hectare, an input of over 550 kilos of N per hectare, and only a 14% nitrogen use efficiency, and a whacking surplus to 487. Now, these would be housed farms importing lots of feed onto farm, high yielding cows, and it's where what led into problems in Holland. I've got some data from Germany, and as we say, the Germans are very efficient. So we've got an end balance of somewhere close to this magical figure of 100, and a nitrogen use efficiency of 40%. So don't forget, Lydney, we're looking at 24%. The Germans reckon they can get it up to 24%. Looking at the phosphorus side of things, a lot of work being done in Ireland, and again, the focus on Lough Neagh in Northern Ireland has really pushed some of the work looking at phosphorus. We've got some data looking at P inputs and P outputs and P balances. Again, P balance not very different. At Lydney, we're looking at 11. They've got average P balance of 9, but they've got a phosphorus use efficiency of closer to 70% on average. But it is an average, and they've got this huge variability. They did 21 farms in this study, and they had phosphorus use efficiencies between 2 and 137%. Massive variability. The work up at looking at Lough Neagh, they're suggesting that in order to reduce P balances, need to go down to about 5.5 to get all of their water courses down to where they want them. Currently, we've got a P balance limit imposed on those farming in Northern Ireland, and there's a proposal to reduce that down to 8. So, if a similar was to come in, Keith, you're not far off where we need to be with that 11 kilos. If we took some of that P, even halved your TSP input, you'd be well below. The big proposal really is to try and get the P reduced in feed. That's probably the most efficient way of reducing P output coming from a farm. So, all right, there's a lot of text on here, and I'm just chucking these up as areas where we can look at improving nitrogen, improving phosphate use efficiency. Most of the studies say, well, actually, if we grow more home-produced forage and stop buying stuff in, we can improve our NMP balances. There are certain areas of technology, looking at calibration of spinners and GPS spreading. We're looking at, we can now do a soil test for how much organic nitrogen you've got in the system and how much is likely to supply in the year, so we can tailor our nitrogen applications on an individual field basis. All through this presentation, we've talked about, an average of 150 kilos of N per hectare. Your farm's not average, as in every field on your farm is different, and we should be tailoring our nitrogen inputs to match the response curve and the soil health and the soil nitrogen supply in each field. But we don't. We just chuck the whole grazing ground gets, I don't know, 30 k's per round, irrespective of how much grass it grows and how much soil nitrogen it delivers. So there's tons we can do in terms of looking at technology. There's all the areas that I really don't know an awful lot about. So the biostimulants, the liquid fertilizers, those sort of things, huge area we can explore to see what improvements we can make on accessing some of that massive store of soil P and soil K, nitrogen that we've got. Still lots of work looking at slurry treatments. Lots of people looking at acidifying slurry to try and reduce ammonia loss. I say there are numerous there. Read down, take your pick. And it's really about identifying which suits your farm and what you're interested in. And I hate the idea of bullying farmers into doing stuff that they're not interested in. So pick 1, 2 off those lists that you think, actually, yeah, I can see us doing that. I can do some research on that. And focus on a couple of areas. But unless you know your whole farm balance, you can't start saying, well, where's my issue? Do I need to deal with it? So yeah, food for thought in that, where do we start? I think they're an excellent way, the farm gate balance, to look at this whole nutrient use efficiency. And they're easy. That Planet provides you a really simple structure. And I say a lot of that data already exists. If you've done your carbon footprint, then you type that data into Planet and it will convert all those carbon numbers into nitrogen and phosphorus. If I'm growing 12 tonne of dry matter, I'm sorry, but the nitrogen balance is going to be positive. I think Brendan's right. If we could get that end balance down to somewhere around about the 100 mark by, improving my soil end delivery, incorporate a little bit of clover, I'll let you do that. I'd still argue that it's an input. My P balance, that 10 kilos is great. And I say the number of farms I still see at 20, 25, 30, still using products like 2555 coming on farm, not testing regularly, and applying blanket covers of slurry everywhere. I think your farm balance, if you're very high in P, it really does flag up that we need to start exporting. And that can either be as a form of slurry or it can be as a form of growing crops and exporting those off farm. So I say we've got numerous options, and it's about taking the time and the effort to really think about what impacts on your farm and what we're going to choose. Okay.
Chris, what would you say would be the low-hanging fruit for Lydney then, and what benefits are they going to see to their bottom line as a business by going down this route of trying to maximise nitrogen and phosphate efficiency?
Okay, so I would start with, we identify the paddocks that aren't growing 12 tonne. So you go through and you find out which are your poor performing fields that chances are still getting the same amount of nitrogen as everywhere else, because that's an inefficiency. And what we tend to do is that if a field's only growing 8 tonne and everything else is growing 10 or 11, what do? Oh, let's give it some more fertilizer and kick it. Wrong answer. We find out it's like a cow, that if last year your cow did 6,000 litres and this year she's doing 4.5, you don't just feed her some more to try and get more milk. You find out what's wrong with her and you address it, or you get rid of her. And this is what we start. We've got the way of, Keith and Gavin are busy plate measuring. We've got annual figures for fields. So we identify those fields that aren't performing and sort the issues out. Is it a soil structure issue? Is it a soil chemistry issue? Is it the fact that the ryegrass percentage has dropped? What's wrong with it? And then so on that simplistic level, on a field basis, we can start addressing those. The other ones would be protein levels in cake. And again, we have quite often a blanket approach. Plenty of farms are looking at reducing down from 18s to 14s. We've got the tools like milk urea levels to address, to look at how cows are performing. So that's another one we'd look at for the nitrogen side of things. Phosphorus, in the big scheme of things, wouldn't it be lovely to have a lower P status ration? At the minute, we haven't got the feed companies on board. They've tried to do it in Ireland, that they've succeeded in Holland. It will put the cost of a ration up to have a lower P status ration, but that's a big area we need to start looking at. So yeah, the field-based would be my starting point, and then maybe some of the ration side of things as well.
And Keith, Gavin, obviously it's a little while ago since this whole concept was brought to light by Brendan when he came to the review. What changes have you made so far, and are you seeing any benefits off the back of them?
Changes so far. One thing we got stuck into straight away was addressing soil pH. Fact that it hasn't rained for about a year now, it's very hard to tell whether we've had a good result from it, but obviously we will have. And stepping up our reseeding as well. I think we got very much behind with reseeding. So without wanting to reignite the Lee-Chris debate on clover, but I think probably the point Chris is making is doing things in the right order. Have you got the right plants there? Is the soil chemistry right? Is there no compaction? It's not just a case of introducing some clover and everything's wonderful, but clover is part of that, but we need to get those other things right first, I think, which is what we're setting about doing.
It's interesting, Tom. I think if you had a nutritionist sat on the panel, we'd probably come from a different direction. I'm always swayed by grass and soil, and that as a starting point. But as I say, the whole idea of this whole farm balance is there's a big area in terms of feeding animals, animal nutrition, that can play a big role in it as well.
And question for Lee, as a processor, what methods would you like to see farmers taking to go down this route of nutrient balance?
Thanks, Tom. Yeah, I just keep coming back to this thing. Let's not chase one outcome. So if we chase carbon, other things can be compromised. If we chase nutrient balance, other things can be compromised. I back what Chris has said. Overall, it's healthy soil, isn't it? If your soil is as healthy as it can be, you'll probably use less fertilizer because you'll be satisfied with the yield. But if you're applying fertilizer to compacted soil with low soil organic matter, it's a sticking plaster, perhaps making up for other weaknesses in the system. So I don't see any time soon that we'll be, in any way forcing farmers to treat their nutrient balance as a key outcome. But carbon footprinting, nutrient balance, doing things that are sympathetic for the river, that's more of an overarching approach. And we'll know, I think, well, we do already know, we know these numbers now for all 700 of our farms. We've done the calculations, so we know what the high quartile and the low quartile is. And I think perhaps with Chris's help we can understand if which of the high users are getting good yields, but which of the high users are actually getting low yields despite chucking a load of fertilizer on. So that's where I think the real groundbreaking work's going to happen. It's not high is bad. It's high is bad if you don't get the outcome of it for it. Hopefully that helps, and it's not too wishy-washy.
No, thank you. And we've spoken a lot about what's going into the cow, what's coming out of the cow, what's going onto the ground, and what's being taken off in terms of grazing. One thing we haven't really touched on is genetics. Does genetics have much of a role to play in this?
We can start both ends. So grass genetics, so a huge, DEFRA's targets, or the plant breeders' targets used to be about growing more grass. That's not on their agenda anymore. They're looking at grass that is more efficient, has a bigger rooting mass, is more able to capture nitrogen. We're looking at breeding grasses that will function at P-index 1 rather than P-index 2, so a lower phosphate demand. And that's the whole animal genetics and looking at feed conversion efficiencies, beyond me, Tom. But yeah, that's where a lot of the focus is. And I say, when we look at that whole rumen activity and the fact that it's such an inefficient beast, what supplements, a lot of the supplements that we're looking at the minute are targeted at reducing methane, but in just the same way we can look at reducing nitrogen or improving nitrogen that's going off in milk and meat. So yeah, the genetics, huge role to play.
So Keith and Gavin, what next for you? Where do you see you taking this to get those next efficiencies?
Getting our soil structure and health right, I think that's one of the things that's majorly important to us, because most years we've got enough moisture to get fertilizers on and apply fertilizers, but I think what's holding us back is our soil structures. We've got reasonable amount of compaction, I would say. I think running cows over our clayey, well, silty soils every year after year, I think we get a reasonable amount of surface compaction that we could better alleviate to get the roots down deeper, to get better results from, well, get more grass growth out of the soil itself.
And does sward diversity play a role in that as well?
Like certainly clover and grass. I think there's some room for chicory and plantain in that as well. I think plantain helps with nitrogen efficiency. Chris might know a bit more work about that, but it's been sort of proven that you get better nitrogen efficiency and less nitrogen losses if you're using plantain. So I think actually if the chicory and plantain, our favourite has been plantain, to be honest. It just, the cows seem to like it a little bit better. It's actually easier to plate meter because it doesn't grow up so vertically as chicory can do, which makes plate metering difficult. So as well, allocations for cows becomes more difficult.
I think it's worth saying, Tom, that for everybody, your farm is just one big experiment. And when we talk about dropping nitrogen, a lot of people are scared to do it. And all I'll say is, right, we'll do 80% of the field at your standard rate and drop it by half on the last bit of field. You can plate measure both bits, see how much grass you haven't or have grown. I worked with a guy down in Pembrokeshire, and we ended up halving his nitrogen applications from June. And in total, we grew 8% less grass over the year. So, big saving in nitrogen, small amount of dropping grass growth. So we were then looking at trying to improve his utilization. And it might be that a lot of people are chasing these marginal kilos of dry matter of grass by this extra nitrogen. And for many people, they wouldn't see much of a difference if, rather than going with 35 kilos per round, you went with 25 kilos per round. Start with the little changes, and you've all hopefully got some way of measuring with a plate meter or cutting, just to monitor what happens.
Fantastic. So I think that's taken us up to about time, or a little bit over, to be fair, but we did have some good questions there. We have unfortunately just lost Lee, so I'd like to thank Lee for his input today, but come to both Gavin and Keith and you, Chris, for your take-home messages from today. Gavin, Keith, do you want to start us off?
I think reiterating what Keith just said, really, our take-home message is soil health. We've just got to concentrate on, make sure we're optimum on all the basics even to start with, and compaction. Look at that, do that, get that sorted first, and then start experimenting, as Chris puts it, which is right. It's on reducing nitrogen or addressing those balances.
Chris?
Yeah. Well, I was just going to say more diversity, but carry on, Chris.
Yeah. No, again, I'd just say have a go. The numbers aren't difficult. There's a nice free setup within Planet to do it. We can get easily fixated on nutrient management plans, looking at soil, and miss out on the big picture. I see an awful lot of nutrient management plans that live in a filing cabinet waiting for an inspection, don't tell you anything particularly, whereas your farm nutrient balance tells you an awful lot about your system. And I say, for most of you, the data's already there. You just need to put it into the right format within Planet, and it'll give you your farm nutrient balance it shouldn't take more than an hour or so.
Fantastic. Thank you very much. So that takes us up to time. Thank you all for your input today. Thank you for everybody who's tuned in to watch. Just to make you aware, go onto the AHDB website, have a look at the events page where you can see forthcoming or upcoming webinars, an awful lot of face-to-face events happening throughout Calf Week in September, and following on from that, we have the Healthy Herds campaign. So have a look out for that activity. As we said at the beginning, there will be a survey. So if you could fill out the survey, that really does help us to make these events better and suitable for you as viewers. Thank you very much for your time, and hopefully see you soon.